Let me introduce myself. I used to work at Google, then ran my startup FutureCam, then worked as CTO of a startup. I now work as consulting CTO with multiple companies at once. Today we are going to talk about extensions. Extensions are a feature in Swift that let you add functionality to a class that already exists. And even if you're not a Swift engineer, this video is worth watching because it gives you new ideas about object-oriented programming and effective structuring of your code. Let's look at an example of an extension. Let's look at AV Asset Writer input. An AV Asset Writer is a class that creates a video file on disk by encoding using some codec like HEVC. So you give it input and it encodes it using the chosen codec and writes a file. And it uses a helper class called an input, asset writer input. We have defined an extension, and extension is how you add things to an existing class. And we have added three things. Let's look at this one. You're adding a convenience function or a convenience property called width onto the input. And it has an implementation. So this is a getter basically. So the way you invoke it is if you have an input. If you didn't have an extension, you had to do this. With the extension, you can just do this. You use it as if it's an inbuilt member of this class. If you look at Apple's documentation, if you look at these properties like transform or preferred volume or any of this stuff, right? Output settings here. The same way you invoke output settings, a built-in property like this, you invoke the property you've added in the extension. So from the user's point of view, it is part of the class. This is much cleaner than dumping it in a util class. In a traditional object-oriented language like Java, which doesn't have extensions, you would have a class called, I don't know, writer util. And you would have a function called width. And you would take in an input asset writer input. And you would define it this way. And the way you would use it is let width equal to writer util dot width for input. So you can see how cluttered it is compared to this. Because here every time I use a property, I have to think about is it in writer util or is it somewhere else or is it a part of the class itself. Right? That's cognitive load. You have to stop what you're doing, stop thinking about the business logic and focus on these irrelevant details. You don't want that. You want it to be natural to use. As Swift recommends, evaluate your design by writing some code that invokes your function and see how natural or unnatural that is. Don't look at the implementation, look at the call side, the usage, which makes a lot of sense. You can use extensions for many other purposes than just building a wrapper like this, than just a convenience function I meant. You can build a bigger wrapper. So let's look at AV capture photo output. Here, You have this take photo function, which takes a photo and invokes these callbacks for you. This callback is just before capture. This is immediately after capture. This is when the processing is finished. So after the capture finishes, it takes some time to process the image and then invokes this callback. This is how you use it. You can invoke it using closures. So if you look at strange, okay, I can't find a call set. Um, but anyway, yeah, never mind. So unfortunately, the lower level API that this function is implemented on top of doesn't support callbacks. It has a traditional class-based thing like this. So you have to define a delegate class, you have to implement this protocol or interface in Java speak, and so on, right? This builds a wrapper. This is a wrapper class. It conforms to the protocol that iOS expects and invokes closures for you. So for you, it is convenient. This is a more substantial wrapper than what we saw earlier, the width function. Moving on, extensions can also make the code easier to use by handling some case underlying API doesn't. Here, for example, this represents a camera, such as a wide-angle camera, tele, front, ultra-wide, etc. And to use a camera in iOS, if you want to switch to a particular camera, say you want to switch to the tele camera, you have to add that camera to the session, an AV capture session, which represents the camera session. That is how you switch to a camera. But you also have to remove the other cameras, otherwise you get into an invalid state. You get an exception saying you can't have two cameras at once. This detail is abstracted out by this API. So anybody can call add safely, and whichever cameras conflict with the given camera are removed, which is all of them. However, if there's a microphone doesn't conflict with any of the cameras. It is also an AV capture device input, but that is not removed. Only the cameras are removed because you can have any camera along with a microphone, say to capture a video, or you can have a camera without a microphone to take a photo. All those cases are fine, but you can't have two cameras. So basically, this extension fixes one of the underlying complexities of the API, the complexities of the underlying API. So you don't have to worry about it anymore. Another example of what an extension can do is thread safety. If you look at this one, iOS has a request authorization function, which which shows a prompt. Can this app send you notifications? And then it invokes a callback. But the problem is a callback can be invoked in any queue or thread, and you don't want that. You want it in the main queue to have fewer race conditions or no race conditions. So I've defined a helper function request authorization in main queue, whose job is to redirect the callback onto the main queue. So it invokes the underlying API with a callback, and the callback can execute on any queue at all, but it calls this helper function in main queue to run this again on the main queue. So thread safety is another thing you can take care of in an extension. You can also add an initializer. Here, for example, this adds an initializer or a constructor in Java speak. It chooses the file type automatically, and not all file types work, like MP4 may work, but others don't work. I'm not sure about MP4 as well, but move is like the best one to use. So it takes care of that detail for you. You don't need to worry about file types. You need to call start writing on a writer before you can use it. Again, it takes care of that. You need to add an input. It takes care of that. So the process of creating an asset writer requires 3-4 steps. And this convenience initializer takes care of all of them. So that is another use of an extension. You can also work around bugs. This function getVideoTrack gets the video track from a given file, which is represented by an AV asset. And the way you do it using the native iOS API is you call tracks with type video on the on self or this. And you can have multiple video tracks, you pick one. However, this API is buggy. It often returns nil. So there's a workaround which is you call something else, and when that is done, then you load the tracks. So these kind of workarounds for buggy iOS APIs can also be implemented in extensions. You can also implement significant functionality like analytics. This class comes from Firebase. We use Firebase Analytics in FutureCam. And it has a lot of, these are all the keys. And if you want to log that a time lapse was taken, you call this function log time lapse taken, and it logs the event to Firebase. We also have a media taken event. What that represents is any kind of media, be it burst, time lapse, long exposure, light trail, any of them were taken for convenience. It's redundant, but for convenience. So that is taken care of here. There's no chance of you forgetting to log this in one of the cases. And then FutureCam has hints which guide you on how to use the app better. Whenever a hint appears, an event is logged again. The app uses a freemium model where you get 10 photos free and 10 long exposures and 10 time lapses and so on. When you exceed the count, it becomes locked, that particular mode. So if you've taken 10 time lapses, the time lapse mode becomes locked. And again, that gets locked to Firebase here. If you receive a memory warning from iOS, that is locked so that we can realize that we are running against memory limits and optimize our code. Sometimes you may get a prompt saying, would you like to give feedback to improve the app? If the user says yes and enters an email ID, that is logged here. Like we are using Firebase for this purpose. It's not meant for this purpose, but we are misusing it. And then when an error occurs, that is also logged to the server. All the parameters are extracted, file name, line number, function, class, any message, any arbitrary map of parameters. All this information is extracted and logged. So as you can see, this extension has a lot of functionality, which were implemented via an extension, rather than having a separate class called Analytics Manager or something. So extensions are very powerful, but they can't do everything. Let's talk about what they can't do. They can't override a function. They can't change the behavior of a function. So for example, if you have a video class and a save function that saves the video to the gallery, you can't change its behavior to reduce its resolution and save it. You can only use an extension to define a new function like save after downscaling. You also can't add properties or variables, stored properties to a class. So now that we understand what extensions do and don't do, what are the advantages? One is they eliminate the need for subclassing. And the problem with subclassing is every time you create an object, you have to stop and think about whether to create an instance of the subclass, which in turn creates some more problems. You may not be able to change the code that creates the object. For example, in FutureCam, when you take a photo, iOS instantiates a class that represents the photo and hands it to you. We can't tell iOS to instantiate a different class. So that's a problem with a subclass. Even if you were to define it, it wouldn't get instantiated. The second problem is, if you ask which class should we instantiate, the question may not even make sense. For example, if you look at the AV asset writer extension, it's just a different, or asset reader, which is a simpler example. It has a similar convenience initializer that creates a reader. It's just a different way of initializing the same reader object. It's not a different kind of a reader. So if you ask yourself, if you were to not use extensions, you might create a subclass. Then when you ask yourself which type of reader do I want to create right now, it doesn't make sense because after creation they are the same. So that's the second problem with subclasses. Third, defining a subclass can interfere with a class hierarchy. If there is already another subclass, everyone must now choose which subclass they want to use. For example, if you were to define a subclass of asset reader called better reader, so let's say we do that, right? And this is the iOS class, which we are not going to define. I have compiled it, I have put a comment, otherwise I'll get a compiler error saying this class already exists in iOS. Now, instead of doing it this way, suppose I were to say class AV asset reader better reader. I could define a subclass with this stuff, this initializer and all that here. But there might already be another class. So if you say hardware accelerated reader, right? This uses hardware acceleration to read the thing, read the file and decompress it. If you end up with this situation, now everyone must decide which of the two they want. Whereas with extensions, people don't need to make that choice. All AV asset readers get this helper function or constructor or getter or setter or whatever it may be. They don't have to choose. So for these reasons, I put as much logic as possible in extensions. If I define a global or static function that takes in a class as an argument, I think about whether I can instead make it an argument on that class. So for example, suppose I have a global function, rotate image, which takes an image. And it has some code. Let's say this is a static or a global function to keep it simple. I then ask myself, can I make it an extension function? And yes, extension image func rotate with the code. Now it's more natural to use. Or if I define a subclass, but it doesn't override a superclass function, it doesn't need to be a subclass. So I make it an extension. And we may not know ahead of time whether what we are writing should be written as an extension or is better as an extension. So I write the code naturally and then look at it and refactor it. In summary, extensions hugely help with readability and understandability. They reduce cognitive load. They help you design a system that feels lighter weight than it would be otherwise. Use extensions.